Balancing Chemical Equations, Lesson 2. Rule number 3. If an element is used in more than one formula on the reactant side or the product side, balance it last. If we take our elements here, lead, carbon, oxygen, hydrogen, and chlorine, we can do our element count of lead, carbon, 3 oxygen, 1 hydrogen, 1 chlorine. On the product side, 1 lead, 2 chlorine, 2 hydrogen, 1 carbon, and 3 oxygen. Now, if we take a look at this problem, oxygen is already balanced. So, if we follow rule number 2, now we'll go to hydrogen. I have 2 hydrogen on the product side. I need 2 on the reactant side. So I can take the hydrogen, multiply by 2. 2 times 1 hydrogen is 2. 2 times 1 chlorine is 2. And we have a balanced equation. Lead is balanced, carbon is balanced, oxygen is balanced, hydrogen is balanced, and chlorine is balanced. Now if we go down to the equation below, in this equation we have hydrogen, carbon, and oxygen. I have 2 hydrogen, 1 carbon, 3 oxygen on the reactant side. On the product side, I have 2 hydrogen. I have 1 oxygen, 1 carbon, plus 2 more oxygen. If oxygen is used in more than one equation on either the reactant side or on the product side, here we have oxygen, and here we have oxygen on the product side. I want you to circle this, and we list each oxygen separate. I have 1 with the H2O, and I have 2 oxygen with the CO2. We list those separate and circle it. Now the circle means to wait and balance this last. Now this particular equation, if we take a look, hydrogen is balanced, carbon is balanced. I have 3 oxygen on the reactant side, and 1 plus 2 equals 3 on the product side. So this equation is already balanced. Let's try another one. Here I have lead, carbon, oxygen, and I have carbon listed again. Carbon is listed in 2 places, but under the arrow, I only list it 1 time. Now if we go through our count, on the reactant side, I have 1 lead, 1 carbon, 3 oxygen, plus 1 more carbon. We're going to circle this, and that's to remind us to balance this last. On the product side, I have 1 lead, 1 carbon, 2 oxygen. Now, if we follow rule number 2, we're going to balance oxygen first. Now, the least common multiple between 3 and 2 is 6. So I need 6 oxygen on the product side and 6 oxygen on the reactant side. So on the product side, 2 times 3 will give me 3 carbon and 6 oxygen. On the reactant side, I'm going to finish balancing my oxygen. I have 3 oxygen. I need 6, so I'm going to multiply by 2. That will give me 2 lead. I'm not going to total up my carbon yet. I'm going to skip that. And 2 times 3 oxygen is 6. Oxygen is balanced, but lead is not. I have 2 lead on the reactant side. I need 2 lead on the product side, so I'm going to multiply by 2. That will give me 2 lead. 2 times 1 is 2. Now let's take a look. I have 3 carbon on the product side, and now I'm going to do a total of my carbon on the reactant side. 2 times 1 carbon is 2, plus 1 more carbon gives me a total of 3. This is a balanced equation. Let's try another problem very similar to this. On the reactant side, I have iron, carbon, oxygen, and carbon listed again. Now remember, we only list carbon one time. On the reactant side, I have 1 iron, 1 carbon, 3 oxygen, plus 1 more carbon. And I'm going to list them separately. I'm going to circle that and wait till the end to actually do my total for carbon. Now on the product side, I have 1 iron, 1 carbon, and 2 oxygen. Again, I will start with oxygen. The least common multiple of 3 and 2 is 6, so I need 6 oxygen. So on the product side, 2 times 3 gives me 3 carbon. Okay. 3 times 1 carbon is 3. 3 times 2 oxygen is 6. On the reactant side, I have 3 oxygen. 2 times 2 times 1 iron is 2. Can't do carbon. 2 times 3 oxygen is 6. All right. I have 2 iron on the reactant side. I need 2 on the product side, so 2 times 1 is 2. My iron is balanced. My oxygen is balanced. On the product side, I have 3 carbon. So let's do a count of the carbon on the reactant side. 2 times 1 carbon is 2, plus 1 more carbon is 3. So this is balanced. Let's try another problem here. Now we're going to go through this the long method because we're not into polyatomic ions. So we're going to list our elements in the order they appear. So we have aluminum, oxygen, hydrogen, and sulfur. Oxygen was used here and here on the reactant side. So that tells us we're going to have to list them separately when we do our total count. Now on the reactant side, I have 2 aluminum, 3 oxygen, 2 hydrogen, 1 sulfur, plus 4 more oxygen. We'll list them separate and total them up later. Now on the product side, I have 2 aluminum, and we got a situation here where we have SO4 in parentheses followed by the subscript 3. That means we're going to multiply everything in parentheses by 3. So 3 times 1 sulfur is 3. 3 times 4 oxygen is 12. Then I have 2 hydrogen plus 1 more oxygen. Now if we take a look, aluminum is balanced, hydrogen is balanced, so I'm going to have to go to sulfur. Sulfur has an odd number other than 1. It has a 3. So I have 3 sulfur on the product side. I need 3 sulfur on the reactant side. So I'm going to multiply by 3. 3 times 2 hydrogen is 6. 3 times 1 sulfur is 3. I'm going to do the oxygen later. Now if I take a look, my sulfur is balanced, but my hydrogen is not. I have 6 hydrogen on the reactant side. I need 6 hydrogen on the reactant side. So I'm going to multiply by 3. 3 times 2 hydrogen is 6, and we'll total the oxygen later. Now if we look, aluminum is balanced, hydrogen is balanced, sulfur is balanced. So now I need to do the totals for my oxygen. Now I'm going to start on the product side. 3 times 4 oxygen is 12, plus 3 times 1 oxygen is 3, which gives me a total of 15. On the reactant side, I have 3 oxygen here, plus 3 times 4 oxygen gives me 12, which gives me a total of 15. So this equation is balanced. We'll try another one here. This is the equation for photosynthesis. I list my elements, hydrogen, oxygen, and carbon. On the reactant side, I have 2 hydrogen, 1 oxygen, 1 carbon, plus 2 more oxygen. So we'll balance oxygen last. On the product side, I have 6 carbon, 12 hydrogen, 6 oxygen, plus 2 more oxygen. Now, according to my second rule, if you can't balance oxygen, we're going to go to hydrogen. Now, on the product side, I have 12 hydrogen. I need 12 on the reactant side, so I'm going to multiply by 6. 6 times 2 hydrogen is 12. We'll do the oxygen later. Hydrogen is balanced. Now I'm going to go to carbon. I have 6 carbon on the product side. I need 6 on the reactant side. So I'm going to multiply by 6. 6 times 1 carbon is 6. And my oxygen is now totaled on this side. All right, so the oxygen is finished. So now let's go through and total the oxygen. 6 times 1 oxygen is 6, plus 6 times 2 oxygen, which is 12, will give me a total of 18. Now, I cannot change my formula C6H12O6. That would change the carbon into hydrogen. So I have 6 oxygen here, and I need to come up with 18. 6 plus 12 equals 18, and 6 times 2 oxygen gives me 12, which will give me a total of 18. And this equation is balanced. Rule number 4. If all attempts fail at balancing an equation, I want you to erase what you did and multiply the first formula by 2 and work from there. This will generally work in most occasions, but not all. But this is kind of a last resort, and so we erase, start over, multiply the first equation by 2, and work from there. This is a simple equation. It involves carbon, hydrogen, and oxygen. Now in this case, I have on the reactant side 2 hydrogen, 2 carbon, 6 hydrogen, and 2 oxygen. On the product side, I have 1 carbon, 2 oxygen, 2 hydrogen, plus 1 more oxygen. So I'm going to balance oxygen last. So if we take a look, I should start with hydrogen. I have 6 hydrogen on the reactant side. I need 6 on the product side. So 3 times 2 gives me 6. We'll do oxygen last. And let's see, the carbon, I have 2 carbon on the reactant side. I need 2 carbon on the product side. So if I multiply the carbon by 2, 2 times 1 is 2. Now my carbon is balanced. Now I need to check my oxygen, since the product side has used its coefficients up. 2 times 2 oxygen is 4, plus 3 times 1 oxygen is 3, which gives us an odd number. An odd number is usually not a good sign that things are going to balance. All right, now if we take a look here, 7 divided by 2 is 3.5. So I would have to multiply the oxygen by 3.5. Now, we never use fractions or decimals when we multiply or when we try to balance chemical equations. It must be a whole number. So this is not going to work. My suggestion, and this works most of the time and prevents errors, is to erase and to start over. All right, so we're back to our original numbers. Now, since it would not balance in the first trial, let's try rule number 4. If we take the first formula and multiply by 2, 2 times 2 carbon is 4, 2 times 6 hydrogen is 12. Okay, now let's go ahead and balance the hydrogen, since we're going to wait and do oxygen last. I have 12 hydrogen on the reactant side, and I need 12 on the product side. So 6 times 2 gives me 12 hydrogen. We'll total the oxygen later. Carbon, I have 4 carbon on the reactant side. I need 4 on the product side, so I'm going to multiply by 4. 4 times 1 is 4. Now that I have my coefficients on the product side complete, now I can total my oxygen. 4 times 2 oxygen is 8, plus 6 times 1 oxygen is 6, which will give me a total of 14 and an even number. Now, for my oxygen, I have 14 oxygen on the product side. I need 14 on the reactant side. 2 times 7 gives me 14, and we have a balanced equation. Now, rule number 4 will work most of the time, but there are occasions where you may have to multiply a different formula by 2 and work from there. But generally, the first one will work in most cases. So let's try one more. I have carbon, hydrogen, and oxygen. On the left, I have 6 carbon, 14 hydrogen, and 2 oxygen. On the product side, I have 1 carbon, 2 oxygen, 2 hydrogen, plus 1 more oxygen. Now, according to the rule, I should start with hydrogen first. On the reactant side, I have 14 hydrogen, and I need 14 on the product side. So I'm going to multiply by 7. 2 times 7 is 14 hydrogen. Can't do my oxygen yet, but I will do my carbon. I have 6 carbon on the reactant side. I need 6 on the product side, so I'm going to multiply by 6. 6 times 1 is 6. And on the product side, I've used up my coefficients, so let's total the oxygen in this case. 6 times 2 oxygen is 12, plus 7 times 1 oxygen is 7, which gives me 19, which is an odd number. And this, again, is not going to work out. 2 times 9.5 gives me 19, and I cannot use fractions. So we are going to start over again. So if I take this out, and if we go to rule number 2, or excuse me, rule number 4, when all else fails, multiply the first formula by 2. So I will start here, multiply the first formula by 2. 2 times 6 is 12. 2 times 14 is 28, right? And I'm going to balance my hydrogen first. 2 times 14 equals 28. So hydrogen is balanced. Carbon, I have 12 on the reactant side. I need 12 on the product side, so I'm going to multiply by 12. So now my carbon is balanced. Now I'm going to count my oxygen on the product side. 12 times 2 oxygen is 24, plus 14 times 1 oxygen is 14, which equals 38. And in order to balance this out, I need 38 oxygen on the reactant side. 2 times 19 equals 38, and we now have a balanced equation. Take out the worksheet given to you the day before, and I want you to check questions 1 through 5 on balancing chemical equations. Chemical equations are balanced and on the board. Now turn to the back of the worksheet, and I would like you to complete questions 6 through 10 on the back. And I'm going to give you another worksheet that I would like you to complete the paragraph question and questions 1 through 3. Just a footnote. On the back page of the first worksheet, you're going to see a subscript in parentheses. You're going to see an S. The S stands for solid, L will be for liquid, G for gas, and AQ will be for aqueous. This has nothing to do with balancing the equation. This just identifies the state of matter that particular chemical is in. So I want you to complete 6 through 10. And then on the second worksheet, I would like you to copy down the answers to the paragraph, and I would like you to complete the equations down below, 1 through 3. So I need you to balance the equations 1 through 3 at the bottom of this page. That concludes lesson number 2.